Hi, the purpose of this tutorial is to help you better understand simple graphing of motion. We're going to do some very basic position, also known as speed graphs. Here we deal with the distance an object moves over a very specific time frame. The next one that we're going to be doing is an acceleration graph, and here we're going to be dealing with the velocity of an object during a specific time frame. Let's look at a couple of examples here. If you look at the graph on the left, it deals with velocity over time, and the graph on the right deals with distance over time. We're going to start with the one on the right because that is the most simple one to deal with. Here we have a line that's been graphed at 0, 4, 1, 4, 2, 4, etc. What you need to do is look at this graph and let's give some very specific information. This graph begins 4 meters away from the reference point. Until further notice, we will always have our reference point at the origin, which is 0, 0. So whoever's motion this is graphing, they're going to begin 4 meters away, and then they will continue at 4 meters away from the reference point as time continues. I would like for you to be able to determine the slope of this line. So remember, slope is the rise over run. And here, in order to get from one point to the next, there is no rise. You don't go up or down, so that's 0. And if we're just going to the next point, that would be over 1. So we have a 0 slope. When we have a 0 slope, that tells us that our speed is also 0. So something to remember is slope equals the speed of the object traveling in this particular example. Okay, now if we want to change what that line looks like, let's say we have a different line, and instead of this traveling like this, let's look at a line going like this. Here we see that we begin at the reference point, which is 0, 0, and we want to determine what we're doing. You can tell that as time goes on, you are moving further and further away from that reference point. So because it is a positive slope, we're moving away from the reference point. All right, that's two things we already know. Now I want you to talk about slope. And again, we use m to represent slope. So in order to figure out the slope, we do the rise over run. So if we go from 0, 0 to any other point on the line, let's go from 0, 0 to 1, 1. It's plus 1, which means we have to rise 1 over plus 1, which means we run over 1. So our slope for this line is 1. We can interpret our slope into speed. So since slope is 1, speed is also 1, but we must include our units. It's whatever units that are in our graph, meters per second. And this happens to be a constant speed because we have a straight line. So constant speed equals straight line. All right, so we've got two good examples of that. Now let's talk about what happens when we have an acceleration graph. You will notice here our y-axis is now velocity instead of distance. This is going to be interpreted very differently. So here we do not know where we are. We don't know where we're going. We don't know if we're going towards or away. All we know is what's happening to our velocity every single second or every single time interval that we travel. Here, at the beginning of the journey, or the time it began the data collection, we were going 4 meters per second. After 1 second, we were still traveling 4 meters per second. After 2 seconds, 4 meters per second, and so on. So only things you can tell me here, you have to give me the slope first. So the slope of this line is 0 because there's no rise, and no matter what the run is, you still come up with a slope of 0. This can be interpreted or translated into acceleration. So if our slope is 0, our acceleration is 0. Remember, when we have an 0 acceleration, that translates into a constant speed. Look at the graph. It'll tell you what speed you're traveling at. Here, our constant speed is 4 meters per second. And because it is a straight line, that's what gives it that understanding that it is constant. Let's look at a different scenario. instead of having a zero slope, let's have a positive slope. All right, here we've got somebody traveling, and for each second they travel, they're increasing the rate at which they are traveling. At 0, they're going 0. At 1, they're going 1 meter per second. Let's go over here all the way to 7. They're traveling at 9 meters per second. So it's evident that they're speeding up. We call that speeding up positive acceleration. If we want to quantify that or give it a number, we have to figure out the slope. Slope is rise over run. So if we went from 0, 0 all the way up to 7, 9, we went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we went over 1, 2, 3, excuse me, I should do it here. 1, 2, 3, 4, 5, 6, 7. You went over 7. So in order to simplify that, 11 over 7 is about 1.57. Okay, so on this type of graph, just like on our last example, the slope can be translated into our rate of acceleration. So now our acceleration is about 1.57. Remember, no naked numbers. Let's look at what our units are. Meters per second per second. Remember, that can also be written meters per second squared. There's not a whole lot of other information that I can give you from this graph, or that I want you to give me from this graph, other than the fact that this is a straight line. So that's going to mean it is a constant rate of acceleration. Its acceleration rate will not change unless the line on here changes direction itself. Okay, let's look at these examples here. We've got a position graph, and we know it's a position graph because we have distance on our y-axis, time on our x-axis. Here you see that we have a negative slope. What that's going to tell us is that you started, or you began, away from the reference point, which our reference point is still going to be 0, 0, and you are moving towards it. And that's easy to interpret because you started at 9 meters away, then you were 8 meters away, 7 meters away, 6, 5, 4, 3, 2, 1. On this graph, it's going to show you that ultimately you're going to end up back on the x-axis. In order to determine the speed, let's figure out our slope. The slope of this line is a negative 1 over 1 because I went down 1 over 1. So our slope is a negative 1, and that can be translated into speed. Remember, for speed, we can't use negative numbers because you can't go any slower than 0. So we're just going to take the absolute value of our slope, and it's just going to be 1 meter per second. All right, over here to graph D, which has got velocity on our y-axis, so this becomes an acceleration graph. You can see that as time goes on, our velocity is decreasing. So we are slowing down. Another way to state that is a negative acceleration. Let's figure out what that rate is by determining the slope, and to make it easy, this was just down 1 over 1, down 1 over 1. Our slope is negative 1. The cool thing about acceleration is you can have a negative number. So that acceleration is going to equal a negative 1 meter per second per second. That negative just means slow down. That means we are subtracting 1 meter per second for every second that we travel. Okay, that's going to end our brief tutorial into graphing motion.